Ask My Instructor 3.7.8. Find dy dx by implicit differentiation for the following equation. Our first step in finding dy dx is to take the derivative of both sides with respect to x. Before we proceed, I would like to review a couple of things. Here, I'm taking the derivative of x squared with respect to x. The letters are the same. And the derivative is what you think it is, 2x. What about the derivative not of x squared, but of y squared with respect to x? Notice how the letters do not match up. When that happens, you need to use the chain rule. So you'd have the 2y, but then you need dy dx. You only do this when the letters do not match up. Here, the letters do match up. Here, the letters don't match up. Also, I'd like you to notice the difference between taking the derivative of x with respect to x and taking the derivative of y with respect to x. Now that we have reviewed those concepts, let's proceed with taking the derivative. I use the derivative rule of addition and coefficients. And then the next thing I want to do is I want to write x, radical x, as x to the 1/2 power. And I want to write radical y as y to the 1/2 power. Here is where we need to pay attention to whether the variables match. In the first term, both letters are x. So I'm taking the derivative of x to the 1/2 with respect to x. But the next two terms, there is not a matchup. And so when there is not a matchup, you have to use the chain rule. All right, now take the derivative. With the first term, just a straight derivative. The next two terms, take the derivative as you normally do, but then you have to tag on the dy dx because you're using the chain rule. Go ahead and do that now. All right, so we take the derivative, and for the second and third term, I need to add the dy dx to the process. All right. Now that we've taken the derivative, and remember we're trying to find dy dx. So our next step is to take this last equation and solve for dy dx. So here is the equation. We're going to solve for dy dx. And the first thing we're going to do is we're going to put every term with dy dx over to the left-hand side of the equation. And everything else that does not have the dy dx goes to the right. To do that, all your dy dx's go to the left, everybody else to the right. And this is what I get. The next thing I'm going to do is I'm going to simplify the coefficients and factor out dy dx. 6 times 1/2 is 3. 8 times 1/2 is 4. And now factor the dy dx. When I factor the dy dx, I get this last equation. Right, we're almost there. Next, what we're going to do is we're going to divide both sides by what's in parentheses right in front of the dy dx. Go ahead and do that division. And while I have isolated dy dx, I have done the isolating, but it's not really in a very good form. I want to at least deal with the fact that I've got negative exponents. We've got x to the negative 1/2 and y to the negative 1/2. An easy way to clean this up would be to multiply the top and the bottom by y to the 1/2 over y to the 1/2 and x to the 1/2 over x to the 1/2. So when you do that multiplication, the negatives all fall out and you're left with this expression. Take care. Have a great day.